All right, so 9.3 covers the hyperbolas and rotation of conics. We're going to chunk it into two sections. The first part covering just hyperbolas. Hyperbolas is the fourth and last conic that we're going to cover. So by the time we're done with today, you'll have gone through circles, parabolas, ellipses, and hyperbolas. That's what will be on your test in addition to what we're going to cover on Monday, which is the rotation of these, like what happens if I actually physically turn them, would you graph them, that kind of thing. So that's a hyperbola. A hyperbola is the set of all points x, y in a plane, the difference of whose distance from two distinct points, the foci, is a positive constant. So it's like two parabolas turned away from each other. They still have vertices, and they still have a focus on each of those, they're called branches, on each of those sides. And then what we'll learn is they also have co-vertices, almost like an ellipse, and they have asymptotes, which tells you how wide or how narrow to make those hyperbolas. Parts of a hyperbola, the graph of the hyperbola has two distinct parts called branches, so the actual curves are branches. The line through the two foci intersects the hyperbola at 2 points called vertices. And the line segment connecting the vertices is the transverse axis. The midpoint of the transverse axis is the center of the hyperbola. So some parts to your hyperbola. Actual curve is the branches. Points where they would intersect that vertical or horizontal line are the vertices. The line itself is called the transverse axis. And the center or midpoint would be the center. So just like with ellipses, you're going to have a relationship between A, B, and C. Okay, with the ellipse and with these, the distance from the center to the vertex is your A. B is the distance from what's called the center to the co-vertices, just like, again, just like your ellipse. And C is the distance from the center to the focus. So exactly the same as the ellipse. A, center to vertex. B, center to co-vertex. C, center to focus. The difference between the parabola and the ellipse is that the ellipse, c squared equals a squared minus b squared. For a hyperbola, c squared equals a squared plus b squared. If you look back on the last slide, it said that the distance between the point on the, which is now the branch, and the center to each, the difference of those is a positive constant, which is like this. Whereas if you're talking about the ellipse, it's the sum of them that is equal to it. So that's the difference, okay? Again, hyperbola is c squared equals a squared plus b squared, just like your Pythagorean theorem. And the ellipse is c squared equals a squared minus b squared. All right, so standard form of hyperbolas depends on whether the hyperbola's transverse axis is horizontal or vertical. If it's horizontal, it looks like this first one. So there's a lot going on in here, okay? But break it down into its parts. You've got the actual branches themselves, which are here. The red curves are the branches. Where they intersect what's called the transverse axis, which is the one that's going to run through it, okay? Where they intersect that transverse axis is your vertex. That is a distance from your center. And then you get these lines, which are your asymptotes, which are telling you how far to spread the branches. And the way you find them is the relationship between the vertices and the co-vertices, which are b distance away from the center, along what's called the conjugate axis. So transverse is the major axis if you think about it. Conjugate is the minor. But instead of connecting those 4 points, we use those 4 points to turn the parabolas away from them. And again, I'll kind of show you at the breakdown of all of that. And the last thing on here is, again, the focus. The focus always falls inside the parabola shaped, or the branch, just like it does with a parabola. And it is C distance away from the center. Then all of that just shifts if it's vertical. So now the branches point up or down, up and down, not up or down, up and down, which means the vertices are going to be on the vertical axis or somewhere vertical, because this could be a shift away from 0, 0. The focus is now vertical inside those branches. The co-vertices lie horizontal, B distance away from the center. And then your asymptotes still look exactly the same. The difference is where you place your branches. All right, what happens if I shift the center? Then my equation shifts, right? So if I shift the center, notice this got shifted up, this got shifted right. They will still always be vertical or horizontal. So the relationship between the vertices, the foci, are going to be either along the vertical, which would make it the transverse axis would be vertical like the second one, or they would be horizontal, which would make the transverse axis horizontal like the first one. Okay, this one puts together all the equations. So standard form of a hyperbola, notice that the difference is there's a minus between these two terms now. With an ellipse, it was plus. With a hyperbola, it's minus. I don't know what happened here. The end of the word center got cut off. Okay, so the top ones are if the center is not at 0, 0. And the bottom one if the center is at 0, 0. So the H still always goes with the X. The K still always goes with the Y. The difference is that A squared always comes first. So with an ellipse, A squared is biggest. With a hyperbola, it is first. And obviously, it's first because that term is positive. One's going to be positive, one's going to be negative. Sarah.
So if B was bigger, would you change the X or the Y on top of the A?
Nope.
Or X is always
It doesn't matter. So the relationship between the size of A and B has no bearing with the hyperbola. The difference is which one comes first, and the first one should be positive. That's how you know it's going to come first. Okay? So if it's X minus Y, then the A is under the X, and that is a horizontal hyperbola. If it's Y minus the X, then the A is under the Y, and it's a vertical parabola. A vertical hyperbola. Okay? First. Yep, which one's first and which would be positive. Sometimes you're solving, and you'll see an example today, when you're solving and the first term might actually be negative, you would reverse the order then. You would switch it to the first is always positive, and that way the first one determines which is your major or your transverse axis. All right, and then the bottom ones are just if your center is at 0, 0. So if the center is at 0, 0, you lose the K and the H, but everything else is still the same. And then all the way down here, we see that the transverse axis, which is kind of like your major axis in an ellipse, is 2A, and the conjugate is 2B. So just like if I gave you major and minor, you would do 2A equals that, 2B equals that, and solve it. So if it gave you, let's say it gives you vertices, so that's going to give you your A. Then it could give you the conjugate, the length of the conjugate axis. That would be 2B equals blank, and then you would solve it. You just have to know transverse is like major, which is 2A. Conjugate is like minor, 2B. All right, so example 1 says, find the standard form of the equation of the hyperbola with foci negative 1, 2, and 5, 2, and vertices 0, 2, and 4, 2. So I'm going to start with the information that they gave me, and I'm going to plot it so I get my visual. Negative 1, 2, 1, 2, 3, 4, 5, 2. Those are my foci. and the vertices are 0, 2, and 4, 2. So the first thing you should be able to identify is this is a vertical hyperbola or a horizontal. Which one is it? Horizontal, which means what letters come in first? Good. So this is an x squared minus y squared scenario. They're going to go like this. You don't even need to draw them, but know that that would be what they are, okay? Also from this information, I should be able to find out my center, A and C. So my center is halfway between both vertices or halfway between both foci. It doesn't matter which ones you use. You can either count it or you can use the midpoint formula. The midpoint between these two or the other two, 0, what's the 0, 4? God bless you. Doesn't matter which ones you use or if you literally count it and find the halfway point. Either way, you're going to get that the center is 2, 2. Now I got x minus 2 squared minus y minus 2 squared. I already have the top built. What does this equal? 1. I already have half my formula. Yep.
How'd you get the midpoint thing?
So you can either find the halfway point between both vertices or both foci. It doesn't matter. Either way, it's going to be the center. You could literally count from green dot to green dot, that's 4, cut it in half. Or you can take your physical points and find the midpoint. One of them is not going to change. That 2 is not going to change. And the -1 plus 5 is 4. 4 divided by 2 is 2. So you can do it either way. Draw the picture or don't. Okay, so now I need A and B. A is the distance between the center and the vertex. So A is 2. B is not on my graph, but the other piece of information I have is what the foci is, right? Or the focus. Distance from the center to the focus is C, which is 3. With me so far? What's the relationship between A, B, and C? A squared plus B squared. So C is 3. A is 2. Which makes B squared 5. Now, if I was actually finding the coordinates of the co-vertices, I would square root 5 and add it and subtract it from the y coordinate of my center. But I actually plug it in as squared, so you don't even have to go that far. That means the first one's going to get your A squared. A is 2, which means this is 4. The second one's going to get your B squared, which is 5. So hyperbola is plus, ellipse is minus. It's the opposite of your standard form. So if you think about your initial equation, an ellipse is x squared plus b squared, and the c squared equals a squared minus b squared. With a hyperbola, the standard is a minus, and the c relationship is a plus. So it's the opposite. Nope, that's in an ellipse, so it doesn't matter which space it's in for hyperbola. The A is the first being positive. That's how you know the difference. So in an ellipse, A squared is larger. In a hyperbola, A squared is first. Questions so far? So you're going to get 2 different kinds. Here's information. Find the equation, or here's the equation, find the graph, which is this one, okay, or after this one. This is your asymptotes. So each hyperbola has 2 asymptotes that intersect at the center of the hyperbola. The asymptotes pass through the corners of a rectangle of dimension 2a by 2b with its center at hk. This is what determines how wide those branches are. So we know how to find the vertices, we know how to find the center. The co-vertices are going to be B distance away from the center. So this is A, this is B. And then if you make a literal box that connects those sides, then your asymptotes run through the corners of that box. This one's a square. Sometimes it's going to be stretched wider than it is tall, taller than it is wide. That determines how wide your branches go. And then you're going to draw your branches as close to without touching those asymptotes as you possibly can. The equations for the asymptotes are here. If it is a horizontal hyperbola, then it's y equals k plus and minus b over a times x minus h. If it is vertical, then the only thing that changes is your b over a becomes a over b. So it is y equals k plus and minus a over b times x minus h. And these are lines, obviously. So you can either find the equation of the line and graph it using your slope and your y-intercept, or you can make the little box we just talked about. Both give you the same result. All right, so to sketch the hyperbola whose equation is 4x squared minus y squared equals 16. What's the first thing you have to do with this? Good. I got to divide it by 16. I got to get in the standard form, so I'm going to divide by 16. The only thing that can be equal to something other than 1 is your circle, okay? Everything else is equal to 1. So this becomes x squared over 4 minus y squared over 16 equals 1. Now this is standard form. Tell me what you know already. Center's at 0, 0. It's horizontal. A squared is what? 4. A is 2. B squared is 16. B is 4. All right, so now I got my center at 0, 0. I'm going to plot that point, 0, 0. This is horizontal, so I'm going right and left the A, which is 2 that way, 2 that way, and I'm going up and down the B, 4 and 4. So because it just says to sketch it, I already have enough information that I need, okay? I would take my transverse and my conjugate axis and make this little horizontal line, vertical line, and then where they intersect on the corners is what I would run my asymptotes through. The other way to do that is to find the asymptotes. So let's just say it asks me to find the asymptotes. Then it would be y equals k is 0 plus and minus. We said this is horizontal, so it's b over a x minus h, which is 0. Simplifies to y equals plus and minus 2x, which means you have two asymptotes. Y equals negative 2x, y equals positive 2x. So these are lines. My b is 0 for both of them. I'd go up 2 to the right 1, up 2 to the right 1 for the first asymptote, and down 2 to the right 1, down 2 to the right 1 for the second asymptote. Obviously, the box is a lot easier. If it doesn't ask for the asymptote, use the box. Now we said this is horizontal, which means these are my vertices, 2 and negative 2, and I'm going to spread my branches out as far as they can go without touching those asymptotes.
So once you get y equals 2x and then y equals negative 10, what do you plug this figure out to be?
So if you wanted to actually see, if you wanted to use those to graph your asymptotes, then it's slope-intercept form. So y equals mx plus b. B is 0, m is negative 2, so down 2 to the right 1, and positive 2, up 2 to the right 1. But the box is easier. But there's going to be times when you have to say the asymptote, so it's good to know it too. Questions? So if you have the equation, it should be easy to identify what type it is, what my center is, what my A is, what my B is, and then go from there. Okay, this one says put the equation in standard form, then find the asymptotes and sketch the hyperbola given by 4x squared minus 3y squared plus 8x plus 16 equals 0. What do you have to do here first? Complete the square. Okay, the good thing is you only have to complete it once, right? There's an x squared and an x, but there's only a y squared. So you just have to complete the square on the x. Okay, everybody get to here at least. So I got 4 parentheses x plus 2 minus 3y squared equals negative 12. Is everybody at least there? So we've completed the square. Okay, so now again it can't be equal to anything other than 1. So I divide everything by negative 12. And this is why I'm going to teach you tomorrow a way to determine from the beginning how it's a conic, what kind of conic it is. But it's important to wait until you get it in the standard form to figure out if it's vertical or horizontal. Because this actually changes this, right? This becomes negative x plus 1 squared over 3 plus y squared over 4. So it not only just changed, obviously, the left side of my equation, but it changed the order in which this goes, because now what kind of hyperbola is this?
How do you get plus y squared over 4? Because isn't it minus?
It's negative 3 divided by negative 12. So that becomes a positive 4.
But it's like making like a...
So that's why you have to switch it. So from here, I divide everything by negative 12, right? And you get this. The negative could have been down here. Either way. As soon as that changes, it changes the signs on those terms. And by changing the signs on those terms, you have to reorder it. So the positive one comes first. So if you looked at it from the beginning and you said, oh, the y squared is negative, this means this is a horizontal hyperbola, you'd be wrong, because you have to wait until it's in standard form to figure out what kind it is. Now, once you get there, what kind of hyperbola is this? Vertical. What's my center? Negative 1, 0. I didn't get through all your quizzes yet, but in the other classes, super common mistake was just saying that the first term was your x and the second term was your y. So a lot of people on the ellipse or even on the parabola would have put 0, negative 1. Be careful. It's what's with the x, obviously, that is your h, and what's with the y, that is your k. So the center here is negative 1. My a squared is what? 4, which makes my a 2. My b squared is what? 3, which makes b square root 3. Before I even graph, I can find my asymptotes. It's vertical, so this is y equals k plus and minus a over b x minus h. So vertical gets the a over b. So I get y equals, my k is 0, plus and minus, a is 2, b is root 3, x minus a negative 1 becomes plus 1.
How do you know what k is?
K is the y coordinate of your center. Can you leave a square root in the bottom? Nope. So this gets rationalized to y equals plus and minus 2 root 3 over 3 times x plus 1. Yes. The only thing that changes for the asymptote is that it's b over a or a over b. Everything else is exactly the same. So the question is, do I distribute this bottom part, okay? And you can to graph it if it's easy to graph. If not, use the box. But when you're giving it to me as an answer, you'll keep it in that standard form. Okay, so now I've got center at -1, 0. Vertical, so I'm going up and down the A, which is 2. Right and left the B, which is square root 3, and we're going to approximate that to be like 1.7, 1.8. I know it's close to root 4, which would be 2. So then I'm going to go right and left like 1.8. And then I'm going to make myself a little box and pass my asymptotes through the corners of that box. And then we said this is vertical, so it's intersecting the vertices that are on that transverse axis or vertical axis. And I want to make my parabolas or branches as wide as I can without touching the asymptote. All right, example 4 says find the standard form of the equation of the hyperbola having vertices 3, -5, and 3, 1, having asymptotes y equals 2x minus 8 and -2x plus 4. So we're back to flipping the other way around. Now we're given the information about it, and we need to find the standard form. So I'm going to graph what they give me so that I know what this looks like. 3, -5, right, 1, 2, 3, down 1, 2, 3, 4, 5. And 3, 1. Those are my vertices. Already, you know what about this graph? It's vertical. What else can you find? Centers halfway between those points, right? So again, you can either count vertical distance is 6 and then either count down or up 3 to find the center, or you can use your midpoint formula, add the 2 x's divided by 2, add the 2 y's divided by 2. Either way, you should get center is 3, -2. What else do you know already? Or can you find now that you have that? What's A? Close. What's the distance between the center
3.
and the vertex? Good. A is 3. You with me so far? Yeah? That's it. That's all we got so far. So 1, I can already build the top part of my equation because it's vertical, so the y comes first. Y minus k, which is -2, becomes y plus 2 squared, minus x minus h, x minus 3 squared. And I know they're going to be over something, and I know it's going to be equal to 1. So again, you've already built half of your formula, or half of your equation. Now this time they didn't give me the foci, they don't give me the co-vertices, they don't give me the transverse, they don't give me the conjugate. What they do give me is the asymptotes. Okay? They are not in standard form, so the first thing I do is get them into standard form, which would be y equals 2x minus 4 and -2x minus 2. So then what's in front of it is your either A over B or B over A depending on your axis. So this is a vertical one, which means positive and -2 equals positive and negative A over B. They should both be the same number. One should be positive and one should be negative. So it doesn't matter which one you grab. If I say +2 equals A over B, or -2 equals A over B, it doesn't matter because you're getting a distance. You're not getting a sign. So we know A, right? So 2 equals 3 over B, which means 2B equals 3 and B equals 3/2. So a squared is going under the y plus 2. A squared was 3, which means this is 9. B squared is going under x minus 3, which means that's 9/4. You with me so far? Okay, you cannot leave it like that. So for test purposes, you're going to take this and do the reciprocal, multiply it by the front, or bring the bottom of it to the top is basically what you're doing. So it would be y plus 2 squared over 9 minus 4 times x minus 3 squared over 9 equals 1. So if you're going to get rid of the fraction in the bottom, the denominator of the bottom gets pulled to the top. When you write these answers in WebAssign, the format's going to pull the fraction out. So it would be like 1/9, like it was with the last one, y plus 2 squared minus 4/9 x minus 3 squared equals 1. It's going to look like that, okay? Don't stress too much about that format for the test. I'd rather it be this way. So if you get it wrong and you have the work to back it, don't stress out about it. I'm more concerned about the answer than the format that it's in. But you can't leave a fraction in the bottom of a fraction. You'd be multiplying by the reciprocal, which really is just pulling the bottom of the bottom fraction to the top. Questions on that one? So the 2 comes from the front of your asymptote, like when you get it in a standard form. Whatever's on the front is either going to be your a over b or your b over a. Because this is a vertical hyperbola, it's a over b. And then it doesn't matter which one you pick sign-wise because you're finding a distance, right? A is always technically positive and b is always technically negative or positive. But it doesn't really matter because you're going up or down, right, left. Okay, last thing we're going to talk about today is eccentricity of a hyperbola. So the good news is the equations or the formula is the same as it is for an ellipse. It's c over a. Okay. The difference is because c squared is always going to be bigger than a squared, right? Because c squared equals a squared plus b squared for a hyperbola. The difference is that this will always be bigger than 1. So with a ellipse, it's between 0 and 1. With a hyperbola, it's going to be bigger than 1. So you would put c over a, reduce it if you need to. The bigger the number, the wider the branch. The smaller the number, the narrower the branch. So something that is large is going to have a flattened out branch. Something that is smaller or closer to 1 is going to have a more narrow branch. That's all. So this was example 1. In example 1, we had that a was 2 and c was 3. So if I asked you for the eccentricity of this, it'd be 3 over 2 or 1.5 or 1.5, something like that. We did not draw asymptotes this time, but if we had drawn them, you would have seen that this is actually a pretty narrow hyperbola. We just approximated it this time. So the WebAssign does not ask for eccentricity. Please make sure you know how to find it. Okay, just like on your quiz where I put it in a part of your ellipse, it will be a part of your hyperbola for your test. Questions?